Okay, here we go. So we got cut off. We're going to do subtraction now. So in the next one, same functions, but we're subtracting. So we have to take 12 minus 36,
Goodbye.
which should be negative 24x squared. So if these would have had different powers on x, you would have left them separate and just boxed it. But since they have the same variable, same power, they're like terms, we can put them together. All right, f times g means we're going to take 12x squared times 36x squared. That means I have to multiply 12 and 36 together. So let's do that really quick. 12 times 36 is 432. And then if I have x squared and x squared, you add 2 plus 2 and get x to the fourth as the power. All right, so now we've got some division. If I have f over g, that would be 12x squared over 36x squared. What would happen to the x squareds? Cancel, and then 12 over 36 reduces to 1/3. Just divide both of those numbers by 12. So if they do g over f, here's what's cool. If you've already done this one, you know it's going to be this, but upside down. I can just make it 3 over 1, which is 3. So if they happen to have you do the same thing twice, you can use one to do the other. Just be careful which one you're putting on top. Okay, next one. You'll like this one, I promise. These aren't that bad. So if I'm doing f plus g, I will have 16x for the f function. Oh, this is supposed to be g. It has an h. Let's change that to g. So plus 2x to the fourth. These are not like terms because they don't have the same variables. So all I do is box it. You write them down and put a plus sign between. Don't you like that?
Yeah.
Okay. So now if I have g minus f, I have to be careful to put the g one first. So 2x to the fourth minus 16x. Again, not like terms. So I just leave it. Multiplication, you can multiply no matter what, so we will have to do a little bit of work on this one. I have to take 16 times 2, which is 32, and then x times x to the fourth. Remember, this would be x to the first, so 1 plus 4 makes it x to the fifth. So review some of those power rules we haven't looked at for a while. And then if I do f over g, I will have 16x over 2x to the fourth. So 16 divided by 2, that makes it 8 over 1. So I'm going to have 8 in the top. And then if I have x on the top and x to the fourth on the bottom, what will I do with that? X to the third on the bottom. Good. I'm glad you guys remember that. All right.
So
Almost
is it redundant to put x to the negative third on the bottom?
Well, you wouldn't, because this, if you did the 1 minus 4, it'd be x, 8x to the negative third. And then you would do this with it anyway.
Okay.
So the negative third wouldn't be in the bottom. That would be if you were just taking away the fraction entirely. And that rules, it has been a while. So I just sometimes think of it, okay, there's 1 here and 4 there. And I think of them as duking it out, and this one wins. But one of these guys kills one of those guys, and then there's 3 left. It's a little violent.
Very active imagination.
I know. That's how I memorize things, though. All right, so let's look at the next one. I have f plus g. So my f function is negative 5x. My g function is 3x minus 7. You could put those in separate parentheses, but with adding, you're just combining like terms. So we can just go ahead and do that. The negative 5x and the 3x go together, give us negative 2x, and then you just put minus 7 on the end. So you're just combining like terms, pretty straightforward. If I have f minus g, then I would have negative 5x minus, and I've got 2 terms here, so I do use parentheses, at least for that part. Since this only has 1 term, it's not really a big deal. This has 2, so I have to make sure I'm subtracting both of them. So this becomes negative 5x minus 3x plus 7. And then I can put the negative 5 and the negative 3 together, make negative 8x plus 7. Okay, multiplying. So I've got negative 5x, multiplying it by 3x minus 1, or sorry, minus 7. I wrote 7, I wrote 1, I said 1. Ah! It's going to be an exciting video for somebody to watch. Distribute this out. Negative 5x times 3x is negative 15x squared. Negative 5x times negative 7, and negative times negative makes this positive 35x. Now, I promise you're going to like this one. F over g. F is negative 5x. G is 3x minus 7. Because this is really all grouped together, I can't reduce the x's or anything. You just leave it, negative 5x over 3x minus 7. That's it. Waha. And then g over x, I would just flip it over. 3x minus 7 over negative 5x, except usually they won't put the negative in the bottom. They'll stick it out in front of the fraction.
Yeah, I like it.
So basically, you just put them into the fraction, and that's it. Now I'm going to show you one that's a little bit more complicated than that, but it doesn't show up a ton. It will when you take college algebra, though. So make sure that you have seen it. So in this one, it has f over g. So I'm going to have x minus 2 over x squared minus 4. Okay, x squared minus 4 we could think of as x squared plus 0x minus 4. But why would I want to do that? Because it can be factored. So we need to think about numbers that multiply to make negative 4, that add to make 0.
Negative 2 and negative...
Negative 2 and positive 2. So that means the top is x minus 2, and the bottom can be written as x minus 2 and x plus 2. And so the x minus 2s, I could put parentheses on that one if I wanted to. Those could cancel. Would leave me with a 1 up there, and I'd have 1 over x plus 2. So this is something we're going to work on a little bit more later, but I'm throwing it in just in case something happens to show up soon.
Like, subscribe, follow this YouTube channel. Do it.